welcome back to another Cracking the Cryptic video and another GAS speedrun. Now, GAS stands for Genuinely Approachable Sudoku, and these puzzles and these videos have proved very popular amongst people, especially I think the people who are newer to some of the variant Sudokus. We got a lovely email from Angela after the last GAS episode in which she said that these were really useful for newer people who are a bit nervous of engaging with Discord and all the experts on there. So they like to pick up tips from the solving of fairly straightforward puzzles. So that's really good to hear. And we're going to keep doing the series because Clover and Sam Cappleman-Lynes and Philip Newman keep turning out fantastic puzzles on the daily Sudoku thread. Now that is on Discord. Do check it out if you want to see these the day they come out. I'm going to keep on rounding them up. Now, Clover did suggest maybe Simon could get involved in this one, but I don't think that's happening. Anyway, there is so much else happening, though. We've got the Sudoku Pad app out now on 2 platforms. We've got podcasts and set of videos on the channel. We've got Sudoku hunts of various kinds on Patreon, including, of course, the murder mystery hunt. We've got all kinds of things going on and all our apps. Everything's on links under the video, as are all of the puzzles involved today. Now, I'm doing 5 days worth, but you'll find 7 links. And I think we'll explain that as we get to it. No, we won't, because we go through the rules first of all. So I will explain it now. So first of all, we have an anti-diagonal Sudoku. Now, anti-diagonal, that does not mean that these diagonals, I can't do a diagonal like that, sorry, that these diagonals have no repeated digits, which is the rule in X or diagonal Sudoku. What it means is that they have only 3 digits on each of the marked diagonals. So on this diagonal, those 3 digits will repeat once there, and once there. And the same for the other diagonal with, well, I was going to say 3 different digits, but that one will obviously be shared. Anyway, enough about the theory there. The second puzzle, called Tilted Windmills. Philip always gives his puzzles a name. This is an anti-knight puzzle, basically. So digits and knights move apart. Those 2 couldn't be 2s because that would break the anti-knight rule. You do need to know a chess knight's move for that. Obviously, normal Sudoku rules apply. Now, we get to July the 4th. I don't know whether it was because it was Independence Day, but there are 3 puzzles for July the 4th. And we don't know who they're by. So one, and they're all 6x6 puzzles. This is why they could put out 3 on one day. I presume 1 is by each of the 3 constructors. And we've got a 6x6 Thermo Sudoku. So it's normal Sudoku rules, except we're only using the digits 1 to 6 now. A crop key Sudoku, so the white dot joins consecutive digits, the black dots join digits with a ratio of 2 to 1. And a killer Sudoku, digits can't repeat in cages, which show their sums. Then we're back to normal stuff with a trio Sudoku. Now this looks complicated, but all it means is the digits 1, 2, 3 are in circles, the digits 4, 5, 6 are in squares, and the digits 7, 8, 9 are not. And then finally this slightly more complicated looking puzzle, which involves Between Lines and Killers by Sam. And this has killer cages which show their sums, but it also has between lines. A digit on the line has to fall numerically between the numbers in the circles on the end of the line. So those are the rules. Do give these puzzles a try, or any one of them that you fancy. I'm going to try and crack through them all now. Let's see how it goes. Let's get cracking. And we start with this. Oh no, hang on. Let me just reset the clock so that I know how long I've taken. Right. Okay, we've got 6s that give a 6 here by the regular rule. Not using the special rule yet. 6, 2, 8, 7, 3, 4 has got to be there by Sudoku thanks to the given 4s. We get a 2 in one of those cells and a 1 in one of those. And I think Oh, 1 in one of those. I'm going to have to turn to the rule in a moment. Now, what digits can't be on this diagonal? 2, 7, 6, 8, and 9. So this diagonal only uses 1, 3, 4, and 5 as its possible digits. Those two can't have a 4. That can't have a 4. This actually was... I know it could be a 1. That's all right. Those two can't be a 1. So if there is a 1 on the line, it has to be there in this box. Let's have a look at the other diagonal. That can't have 1, 6, 7, 8, or 9 on it. So that's using 2, 3, 4, and 5 only as possible candidates. I don't know if this is the way to go about solving this puzzle. Oh, that can't be a 2. I have a feeling I'm going to have a lot of pencil marked cells at the end of this and no real clue what to do. So that might be a time waste. Let me just... There's a 7 in one of those two cells. So that 7 has to be here because it can't be on the diagonal. Okay, that's slightly useful. Thanks, pencil marking. You did something after all. That can't be a 2. So if 2 is on this diagonal, it's there and there. I don't know, I just don't think I can draw conclusions from that. Maybe I can rule things out of these corner boxes. That might be the... Oh, that's very silly. I should not have listed 4 in any of these because it's already on the diagonals. Okay, now the pencil marks have reduced. Ah, is that really right? That's now a 3... No, I'm talking absolute nonsense. There are 4s in these corners. Why do I even listen to myself sometimes? I've no idea. Right. Okay, so sorry, making an absolute hash of this, but let's carry on now. Slight reset. 8 has to be in one of those two cells, and therefore one of those two. 2, 4... I want to see 9 and 8 trying to do things in places, but they're not really giving me a lot of information. So much for genuinely approachable. I am struggling to approach this. 9, 8, 4, 2. Oh, look, 5. 5 can only appear on one of these diagonals, obviously, and 3 on the other. Ah, is that right? So 1 is on this diagonal. Right, yes, these numbers can't repeat. So 1 is on this diagonal, 2 is on this one, and 1 each of 3 and 5. So if that's 3 or 5, that is not 3 or 5. That must be where 2 is. I think that logic holds. Right, so again, if that's 3 or 5, these are 4 and 1. So that must be a 4. I think that is right. 4 and 1 are on this diagonal, 2 and 4 on the other, yes. Okay, so we've got 4 and 1. No, that can't be a 1. We've definitely got a 2 on this diagonal, so that is a 2 and that isn't. Up here, I don't know which of those is a 2. So, have I learned anything from this? I thought that was going to give me something. This 2, this must be 2, 4, and 3 or 5. No. Oh, Mark, come on, think about it. That can't be a 3, obviously. 9, 2, 8. That has to be a 4 because we need a 4 on that diagonal. So now there's a 4 there or there, but it must be on the diagonal, so it's there. So that's not a 4, as it wasn't anyway, obviously. 2, 4, 7. 1 has to be on this diagonal, so that is a 1, because that can't be. So we're going to get a 1 in one of those cells, which is, we're going to get a 1 in one of these cells. That's not a 1. That doesn't do anything at all. 2, 1, 3, 2. Okay, I am not going to get my full hat quotient on this puzzle, and there's no doubt about that. That's not a 1. Why can't I see the 1 looking at that? That's a 1. Let's get rid of the pencil marks there, because they're lying. Now, a 3, 5, 7 pair. Oh, nearly. Nearly gave me a naked single, but didn't. The 1 in the central row has to be there. Okay. 2, 9. So we've got 8, 6, and 5. That can't be an 8, because 8 is confined into those cells. Wow, this is not easy. That's where the 4 goes on this bit of the diagonal. So we've got a 4 X-wing in columns 4 and 6. It also needs a 2 on this diagonal, so that's there. 2 down here as well. One of those is a 2. Getting all sorts of X-wings now. Being so slow here. Right. Do I colour? Those are 5 and 9. 1, 2, 9, 3, 4, 7, 1, 2, 9, 4, 8. Wow, I don't find this genuinely approachable. This is tough. I mean, it's very clever, but it's not easy. Right, those are all the same. Does that tell me? And they're different from that. Okay, I am colouring now. I don't know whether it's 3 or 5, but it's got to be up there and therefore there. And therefore in one of these two. Oh, and therefore, oh no, somewhere in these two. So it could still be 3. But I don't know. Let's colour the other one. I don't think it's going to do any good, but that's green. Has to be in one of those two. 3 or 5. Has to be in one of those two. It's not that, because that's the purple one. So it's up there in one of those two. And one of those two. And the trail runs hideously cold. Maybe not. Well, yeah, it could still be 3 green. And purple would be 5. That would be 9. I cannot see how to clearly resolve that. 4, 6, 1, 2, 7. Wow, this has ended my hopes of doing a good speed run on this set of puzzles. But this is fascinating. Okay, well, green and purple. So that has to be 8 or 9 because it's not green or purple. So does that. 2, 8, 1. This can't be 3 or 5. So that's 6 or 7. 2, 3, 4. 1, 2, 4, 7. 3, 5. So that is 8 or 9 as well, and that's from 6, 8 or 9. 3 and 5 are both green and purple, both in those, so that can't be 5. My goodness, I'm sure it did not take that to, this wouldn't have appeared as a genuinely approachable puzzle if you actually needed that. I still don't know. That could be purple, so placing a 5 hasn't resolved these, but we've now got 3, 7 and 5 there. So this is a 6. That gives us 6 here, 8 here, 5 here, and now we know that 3 is purple. Okay, so let's put 3s in those cells. 5 is green, so it can go in those ones. Now we've got 7 and 5 to finish that box. 7 and 8 there. I think I've made a real Horlicks of this puzzle, but anyway, it is finally getting done now. That becomes a 9. 8 and 3. This is the sort of puzzle I wouldn't be amazed to find I've still botched in some way and got something wrong, but let's hope that's not the case. I think what I've done has been logical, which is the key thing, obviously. 7 and 3. So sorry, do feel free to point out what I was completely missing here. I think there was definitely something. 2, 8 and 5. So we get a 5 and a 2, 8 pair. This is 1, 3 and 9. Ah, that's good. So 3 there, 9 there, 1 there. That's a 7, and we've got a 4, 6 pair at the top. 5, 3 are resolved. 6, 9 are resolved. All the little pairs are resolved. And we can finish off with 7, 8, 4. There we go. Dear me, that was terrible. 12 minutes there. Okay, but done. And we move on to the next one. Let's reset the clock. Okay, and this is anti-night, isn't it? So we can place a 4 there straight away. And 4 here, we can probably, he says, rashly finish the 4s, but it's looking good now. 4 there and 4 there. Yes, they all work just by considering the anti-night issues. 1, got a lot of given 1s, so they're quite helpful until we get there. Yes, they're all ruled out, so that is carrying on as well. And all the 1s are done. What else are we given a lot of? Let's have a look at 3s in box 2. They're all ruled out, so are those 2. So we can place that, and that, and that. Oh, this is lovely. It is just working, basically. What else do we get a lot of? 2s. So that 2 sees those 2 cells. Ah, no, I was going to pencil mark them, but I can see they're done there, and I think we're finishing off 2s. There we go. We've done 1s, 2s, 3s and 4s, but there's only 1 each of 5, 6, 7, 8, and no given 9s, so it might get trickier here. No, that 6 sees 4 of the cells here. Okay, so that 6 was very useful for a moment. Oh, I see. That 8 sees lots of the cells there, so we can place it. That's 7 into that box, and this 5 into this one. Look at the symmetry on this puzzle. That's so surprising. But how can I start branching out from that? 5 in one of those, 8 in one of those, 7 in one of those. It gets more difficult here. Now, 6 is ruled out of those 2. 5 from those. I don't think that's useful. 7 and 8. But these new positions we've found for... Oh, that puts a 6 in one of those 2 places, but they don't see the same cells anywhere else. I almost feel like I have long ago seen this sort of pattern in an anti-night puzzle, but I don't know what to do with it, so it didn't make a lasting enough impression. Six is confined there. Now they all see that cell. That's not that useful. There would... absolutely certain we're going to have a 9 in the middle, but that is not a logical deduction. That's just from the symmetry in my instinct. Come on, Mark. 5s. So if that was a 5, that would be a 5. We'd have a 5 in one of those two cells and a 5 in one of those two. Ah, 5 in one of those two. It would create that sort of X-wing, wouldn't it? And then, I don't know. Maybe we have to consider what something can't be. That. No, I don't know. These cells are just... all the really useful places have gone. I don't know how you make progress now. Wow, I mean, from a puzzle that was just swimming along being super easy, it has died a death on me. Total sting in the tail here. I don't know. I don't know how to find another logical deduction at all. 5s there. 2, 3, 4, 1, 7, 6. That is 8 or 9. Is that? That's not of any use at all. I mean, that must apply to all these. They must have only 2 possibilities. 7, 2, 8, 1, 3, 4. Ooh, sort of tempting to think about the Fistemafel ring. That would be madness, wouldn't it? Probably would. 3, 4, 3, 2. I don't think it does anything obvious. How does this resolve? If that was an 8, then we'd have 8 here. Wouldn't really do much. That would then become a 7-8 pair. Oh, that's quite interesting. That's impossible. Because, oh no, it's not. You'd have a 5-9 pair up here, which would mean 9. I thought that was going to force all of 7 and 8 into these cells, but that's not the case. Oh, that's close. 8 there would force that to be an 8-7 pair. So we'd have a 5-9 pair here. These would be from 6, 7, 8. 9 would be along there. 9 would be along there. Yeah, okay. Wherever 9 is in these crosses, it's always going to form... it's always going to push it around the grid. So 9 is never going to be in these cells. What does that mean? Oh, these could all be 9. These are either all 9 or none of them are 9. That's what's going to happen, but that's not logic. That's just kind of knowledge. I don't think they can all be 9, or you couldn't put a 9 in the middle box. Ah, so can I prove that they would all be 9 if one of them's 9? Because that isn't going to happen, and therefore I'd have significant progress. What goes here? 5, 6, 7, 8, or 9. Now, if it's 9, none of those can be 9 because it sees them all. If it's 5, it does force a 9 into one of these places. And what does that do? Given that 9s are in all of these plus shapes, one each, having a 9 in one of these inner cells rules 9 out of those, puts a 9 in one of those, and one of those, therefore. And now there would be nowhere for 9 in the central column, because it would always be in one of the one in row 2 and row 8 in one of the plus shapes. And we would have it not in the central column in the central box. Good grief. So that proves that none of these cells in these positions can be 9s, because in each case that will be the same and they'll be kept out of either the central row or the central column. That is extremely hard to see. This is not feeling like an approachable puzzle. Again, I must have missed some better way of getting to that deduction. I literally must have done. And again, I would be absolutely fascinated to see what is so obvious that I've missed there. I mean, it does work, but that felt complicated. Really interesting puzzle there. I mean, it's still, it's not a long puzzle. It's a bit of a vignette, but I'm going to be 11 minutes again, just about, I would say, which is terribly not what I was expecting for these puzzles. 7, 8, and 9. So the 7 is there. 9, 8. We've got an 8, 9 pair here. At the top of the grid, we've got a 6, 9 pair, and I think this is going to work now. 5, 9 in the middle, as suspected, and a 7. Crikey, those two have taken it out of me. Let's get to these 6 by 6s for July the 4th. Now, I don't know why July the 4th. Is it anything to do with Independence Day that we kind of spread it around? Haven't a clue. Oops, accidentally pencil mark that with colour. Now, what does that mean? I don't think this is really the way to go about this. Good lifting these thermos, but I don't quite know what else to look at. 1 has to be in one of those cells. That's not interesting. Those are definitely the same as those, so those two are the same as each other. If they were 4s, they would have to be 5s, and they would have to be 6s. I don't see how that helps. These tiny thermos, what can they possibly do for me? That's close. So if that wasn't a 2, we'd have a 3, 4, 5 triple, and that would be a 6. Then we'd have a 1, 2 pair here. As far as I can see, this digit, which will be the same in both cases, I think. Oh, maybe not. If these were 1, 2, 3, that could be anything from 4, 5, 6. No, that doesn't necessarily apply. Yeah, I'm sure these 3 have to be exactly the same along the thermos. So let's colour those as well, just in case that suggests anything. The trouble is it doesn't, because they don't all see. Oh, I see. They both see that cell. Is that? No, it doesn't mean anything. They're going to be the same, so that can't be a 2 because it would break this. So that is also 3, 4, 5 or 6, but I mean this is just desperation pencil marking. If one of them had to be a 6, one of these two, then that couldn't be a 6, and 6 in column 3 would have to be there. Why would one of these have to be a 6? So can this be a 1? If that's a 1 and that's a 2, then this starts with at least 3. How about for these to be 2s, these purple cells, then we have to have 1s here. I don't know. It's got to be something to do with columns 3 and 4, hasn't it? The fact that 6 doesn't appear. If that was a 6, these would both be smaller, so there'd be 5 and 4 at maximum. Then you'd have 1, 2 and 3 in these places. If that was a 6, but they could be 3 and 4. How on earth does this resolve? Now, I think I saw somewhere we're meant to add our times for the 3 6 by 6 puzzles, but I mean, if this one on its own takes me 10 minutes, I don't know what on earth that's going to leave me for the others. This is monstrous. Okay, purple. Oh, I was going to say it has to be up there, which at least looked interesting, but if it was a 2, it could be there. Let's say that was purple. I don't think it is, but if that was purple, that would have to be purple because it couldn't be on the same line. Purple would obviously be a 2 in this scenario. Then we'd have 1 in each of those. I don't see why not. It doesn't really do anything special. Ah, okay, that cannot be purple, this cell I'm pointing at. If that was a 2, then purple being 2 would put a 1 there, that would put a 1 here, but that being 2 requires a 1 here, so you can't have a 1 there and a 1 in those cells. So purple is not there. So purple's in one of those 2 cells and in one of those 2. And therefore, since purple is 2 or 1, this can't be a 2, because that would be a 2 and that would be a 1, and they both see all those possible purple cells, so that's not a 2. Now we do have a 3, 4, 5 triple, and we get a digit in the grid. My goodness. 6 there. So 3, 4, 5, so we get a 1, 2 pair. Does this work exactly the same way the other way round with 6s? Ah, now we know where 6 is in column 3. That's what we know. So that one is not purple. Purple is now there and is a 1 or a 2. And purple is in one of these 2 places. 6s. Can I do anything? Oh, that's not a 6. So that's not a 5. So now we've got a 3, 4 pair, and that is a 5, and we can place the 6 here. 6, 6, that's a 6. Come on, Damien. That's a 6, and that is a 6, unsurprisingly. That doesn't definitely make this a 5 yet, I don't think. I'm reluctant to take that step, even though it probably is going to be. And in fact, I fear I'm still going to have to make some further deepish deduction. This is not purple, but I don't know that it's not 1 or 2. I don't know which of those is purple. Oh, good grief. Those are the same. That is the different 3 or 4. That doesn't do anything. Now this can't be 2, same as below. So that is 3, 4 or 5 with 1, 2, 3 or 4 there. Now can that be 5? If this was 5, that would be 4, that would be 3. That would be 4. That's if this is 5. Oh no, look, I bet I can work out this can't be 2. Yes, of course that can't be 2, because you'd have 1 there and that would be impossible. There we go. So now we've got a 3, 4, 5 set here. So that is 1 or 2. In fact, this can't be purple, because purple is 1 or 2, not 3, 4 or 5. So that's purple. So purple's in one of those two, but I still don't definitely know. In fact, yeah, they're both looking very attractive as purple. So 3, 4, 5, that's 1 or 2 as well. Now we've got a 1, 2 pair here. 3, 4 and 5. It's amazing that a 6 by 6 can cause such trouble. So that's not purple. That's not purple. This is the other 1 or 2. And that is purple, so that is 1 or 2. So now I can take 1 and 2 out of those two. That can't be 3. That can't be 3. 1, 2. This can't be 1, 2 or 6. That's 3 or 5. So we've got a 3, 4, 5 triple, and that yellow is a 2. And purple is a 1. Wow. Well, I mean, that has taken some doing. 2 there, 2 there. Let's just finish off 2s. Surely I'm pretty much finished with this puzzle now, but maybe not. Just pencil marking literally everything at this point. A 3, 4 pair in the final column, that's a 5. So the 5 down here is there. 4, 3. That's a 3, that's a 4, 3, 4, 3, 4. What a relief. I did not start the clock on this one, which is a shame, but I feel like it's another 10-minuter. I might be wrong about that because it is small, but right, we'll move on to the next. This is going to be a long old video. So crop key 6 by 6. Now with the black dots must help. 1, 2, 3, 4, 5, 6. 5 is not a crop key number, so 5 in row 2 is not a black crop key number. That puts 5 here and 5 here, because black can never be on a, sorry, 5 can never be on a black crop key dot. No, 5s peter out a bit after that. Now these could be 1, 2, 2, 4. One of those must be 3, 6. So that's from 1, 2 or 4. That's from 1, 2 or 4. That could still be from 1, 2 or 4, which is annoying. Not all dots are given, so that can be 3, 6. That's fine. That's consecutive, and it doesn't involve a 6 or a 5, therefore. Yeah, that's very odd, but the single white dot may well be the key to unlocking this. If that's 3, 6, then that's from 1, 2, 4. That would also have to be 3, 6. These two must be... Yeah, if they're from 1, 2, 4, that's 3, 6. So they are, yeah, they must be from the same group of either 1, 2, 4 or 3, 6. Now, if they were 3, 6, 2 would have to be in one of these cells. So 2 would have to be there. It doesn't work. That's really interesting. If these were both 3, 6, 2 would have to be in one of those 2 cells to make the 1, 2, 4 thing work. That would mean that was a 2 and make this a 1, 4, and that doesn't work. So these are from 1, 2, 4. That pair is from 3, 6. That, just by elimination in the column, is from 1, 2, 4. That's where 3, 6 are there. These are 3, 6, obviously. Those are from 1, 2, and 4. This is going to be how I determine which way round everything is, I presume. Now, this can't be 3, 6 now, so they're from 1, 2, 4 and include a 2. So that's not a 2. That's from 3 or 6. Now we've got 3 and 6 here. That can't be a 5, so it's from 1, 2, 4. So this can't be a 1, 2 pair now, because you couldn't fill both of those. So it doesn't have a 1 in it. It doesn't have a 5 or a 6. It must have a 3. It's from 2, 3, and 4. Oops. I was trying to do that. It's from 2, 3, and 4. So 6 is over here somewhere. And down here, there'll be a 5, 6 pair. 6 there and 6 there means that is a 3. Wow, this was intriguing as well. Really interesting puzzle. That is the 6 now. In column 4, we get the 5 there. 3 and 6 are resolved. Don't think I've made mistakes yet. That is from 1, 2, or 4, but there's a 2 in one of those, so that is 1 or 4. Now, is this 2, 3 or 3, 4? There's a 2 in one of those, so these are from 1, 3, and 4. I don't know. How has this run out? I thought after I cracked that, it would be all absolutely done. There's a 2 in one of those, so that's not 2, but that is, because that must go with a 1 or 4. So 1, 4 pair there. That becomes 3. This is 6. This is a 2, naked single. This puzzle is so strange. It really has again subverted my expectations dramatically. That is now a 3, 4 pair. That's a 1, 4, 1, 4. Those are a 1, 2 pair. In fact, we know which way round they go. And now I am just finishing off. Thank goodness. What a brilliant puzzle again. How do these guys come up with brilliances in 6x6s with ordinary rules? You may well ask. Well, that was quick. 5 minutes. I mean, the time has come when a 5-minute 6x6 puzzle is good. Right. Surely this is going to be easier. 1, 2, 3 there. 1, 2, 4 there. They're the giveaways. Got to be a 1 in those cells, and there's a 1 obviously in those. Oh, here we go again. What deduction should I be able to make up here already that I cannot see? Okay, what do these add up to? They add up to 22, 29. One box here adds up to 21. That's the magic number here. So those two add up to 8. That's not a very conclusive total at all. I suppose they can't include a 1. Is that doesn't feel like a valid What if they were the same? What if they were both 4s? Then you'd have a 4 in there with a 3. You'd have a 4 in there, so that wouldn't be a 4. In column 4, that would be a 4. And one up there. Perfectly valid. Although, is it? With a 4 in a 9 cage, it would be a 2, 3, 4 cage. So now you'd have a 5, 6 pair in this empty domino. How are you going to fit a 6 into this box? It would be in here. It's 6, 2. 1, 4, 5, 3. That's all right. And here, 5, 1. Right, if these were 4s, we'd have 6, 2 in the 12 cage, 5, 1 in the 10 cage. That pushes the 1 in the 8 cage down to here, and 4, 3 there. And makes that fill impossible because it could no longer have a 4 or a 2 in it. Okay, well, that'll do. That's not a pair of 4s. That doesn't really help. If that was a 6, this couldn't be 4, 2 because of that. It would have to be 5, 1. This would be 4, 3 again. You'd have 2, 6 here, but that would clash with another 2 required there. So that is not 6. Gonna have to do this one at a time. The trouble is it gets much more flexible. If that was a 2 though, this would be 6, 4. That would be 5, 2. This would be 2, 1. So if this is a 5, no, if this is a 2, that's what I'm saying. And that's put a 2 here. We've got 4, 6, 2, 1. 5, 3, 3, 1. That all works. Curses. Oh, this can't be a 1 because it sees all the cells of the 8 cage. That's a slightly simpler thing. This sees all the cells of the 6 cage, so it can't be a 1. Wow, that's very neat. So we get a 1 there, a 1 in the 8 cage. Now there's definitely a 1 there somewhere. The 9 cage now can't have a 1. This is the way to do this puzzle. So 2, 3, 4, 5, 6. So we've had a 5. That's got to be 3, 4. Oh my goodness, this is neat. 4. That's a 3. 5, 6 there. What do I know going across the puzzle? It's difficult to get across the puzzle. There's a 1. Oh, there's a 1. Oh, one of those is a 4. That's not a 4. So we've got a 2, 3 pair. Yes. 6, 1. 5, 4 at the ends of it. That 6 has fixed this. So now that's 3, 4. We can put in a 5. That's a 3, 2 and 5 are done, 4 and 3 are done. Yes, 4, 5, that's a 2, that's a 3. What a beautiful puzzle again. I mean, these guys are something special with what they come up with here. They really are. 6, 2, 3, 6, 5. Oh, I don't know what that is, 1 or 2. I know now that it's a 2. That is beautiful. Right, I think part of the joy of these puzzles, 6 minutes, just over there. Part of the joy, so my total time for those 3 puzzles, I think the first one took me about 10, so it's about 21 minutes or something. I don't know, you'll be able to tell, but part of these was to try and work out who created them. And that is very hard because they're all brilliant. My gut feel is that Sam is always more interested in symmetry than the others, slightly. And here the thermos did form a symmetrical pattern of sorts, if you allow for those bulbs not being opposite each other. And that was needed to disambiguate it. So that would be my favourite for being by Sam. This was sort of Philip Newman-y to me. Absolutely devious and brilliant. And just subverting expectations. This felt a bit more like Clover. I don't know if that's right. It's my feel. Again, absolute joy, and the fact that I was led on a totally false trail at first, being a bit of a doofus trying to work out what was going on in those two cells before noticing the impact of cells like that, seeing all of those. I don't know. That's how I would see it. Who knows if that's right or wrong. Now I'm going to carry on. My God, this video is nearly an hour already. I've still got 2 puzzles to do. Oh, I was going to say earlier that I thought trio Sudoku was normally fairly straightforward, but we will see. Anyway, let's reset the clock. There we go. So 3 and a 2 there. I can do those. 2 and in fact 3 and 1. This is very much, these trios are well worth thinking of as just 3 totally separate puzzles. So down this column, I'm just looking at the circles so far, and they are easy to fill in if you concentrate only on the circles. That sees 2 and 1. I mean, you know, long may this puzzle continue to be like this, because I could make up some time back. And the circles are all done. That is straightforward. Now, 4 and 5 only appear in one box. So, okay, but 5 is ruled out of those 2 cells. So we get a 5 there. That's 6. This is obviously 6. 6, therefore, is here. Actually, maybe this is all right. And this does look like one of those you can do without, 4 is ruled out of those, yes. Okay, so 4 goes in all over the place. This does look like one of those you can do without needing interaction between all of the digits, which would be very handy. That is just what I would need at this point. 4, 4, one of those is 4. That sees a 4 and a 5, so there we go. 6 there, that becomes a 4. This sees a 4 and a 6. And this is going to quickly get all of these digits done. And again, assuming that the remaining cells don't have some bizarre Y-wing or something, and I don't know that they can, this might go fairly quickly. That has to be a 7. Now, this now sees a 7 and an 8, and that is going to be crucial. That gets some interaction going between the remaining digits. And as I say that, it runs out. 8, 9. It does indeed run out. Do not want to have to pencil mark this. Come on, 8, 7 and 9 in those cells. Oh, come on. Got to find somewhere. Right, 7 here has to be there. One of those is a 7 and one of those. That's not very useful for finishing the 7s. Yes, it is, because it puts a 7 up here. That was a nice touch, actually. So there's not much you can do as a constructor, I would imagine, to disguise things in this sort of puzzle. And I think Clover's done the best that is available there. A little sort of X-wing on 7s. But the rest of the puzzle is feeling pretty straightforward, thank goodness, which slightly restores my confidence in myself. So 7 and 8, 7 and 9. Oh, put those in the Wrong places. Let's try that again. 7, 8, 7, 9. There we go. That's an 8, and that finishes it. Yes, okay, so 3:43. That's better. And one more in this marathon now. So this is Sam's between lines. Oh, right. In a 6 cage, obviously 1 and 3 are in the circles and 2 is in between. So there's another one. 2, so 7 and 9 on the outsides. Where a cage's numbers are known, that is quite helpful. So one of those has to be a 1, which matches up with one of those. And means there's a 1 somewhere here for column 3. This can't be a 2, so that is a 3 in between a 1 and 4. Oh, and look, that resolves the 1 and 3, and that resolves the 1 and 4. Oh, this is another 27, so we've got an 8 with a 9, 7. This has to be 4, 5, 6 now. This number now has to be 1, 2, or 3. Well, it can't be 2, because that would put a 1 in a circle and break the numbering. That has to be a 3 with a 2 and a 9. These are a 4, 5, 6 triple just by elimination. Another one. 7 and 9 with an 8 there. Now 14 must be 3, 5, 6, I think. So we can do that. That is 1, 2, or 4. Can it be 2? Yeah, it could be. Bother. This one, though, is 4, 5, and 6. Yes. Should have spotted that at the start. This number is now 7, 8, or 9. Can it be 8? No, because it would have a 9 in the circle. So it has to be 7 with an 8 and a 1 in the circles. So those are an 8, 9 pair. What about this 19? Should I know? It doesn't have a 5 in it, or a 1, 3, or 4. 6, 7, 8 would be too much, so it must have a 2. Is that right? 6, 7, 8 would add up to 21, yeah. So it must have a 2, and therefore it must be 2, 8, 9. And I still don't know the order. So this now is not 1, 3, 4, 8, 2, 9, or 7. That is 5 or 6. If it was 6, yes, it could be, with a 7 there and a 1 there. In fact, 7 gets placed in this cage. Need to do some regular Sudoku sometimes. 5, 6 pair gives us a 4 there, 6 there. 1, 2 pair here. I can do those. What up here? A 1, 2, and a 4. So the 2 goes there. 4 must go there because 1 can't be on a line. That's probably surrounded by a 3 and a 5, but I don't know that. There's a 7, 9 pair, so this is a 1, 2, 3 triple. 5, 3, 2, 1, 8. Oh, look, there's a 2 looking at that number. 9 fixes the 7, 9. That fixes this 7, 9. Now we've got a couple of boxes done and a third straight away, and that gets me most of a 4th. So 2, 4, 7 triple there. 5, 6, 9 there. That makes this 1, 3, and 8. 8 can't be there actually, because that would require a 1 here. 1 and 5 is 6, needs an 8. 3 and 6 is 9, needs a 5. So this is 5, 6, or 8. Yeah, it could be either. That's irritating. 1, 3, or 8 there. Oh, that can't be an 8. It's just looking at it. Sorry. 3 and 5 in those cells. So this must be a 3, 4, 5 cage now. Perfect. So we get an 8 here. 2, 6, 9. We know where the 2 goes. 6 and 9 around it. 4, 7, 8 at the top. That one's not an 8. This isn't. Oh, those two both aren't 5s now. So 5 goes there. That makes this a 6. got two, no, we've got 3 8s across the middle. We've got a 1 3 pair. That makes this a 2. 1 3, oh, it's 9 looking at that. That can't be a 7. We've got 2 and 4 to place. That's where the 2 goes. That's the 4 in the row. 6 and 7. Oh, still to be resolved there. That is 6 or 8. I'm still going to have to figure out that cage in a moment. Maybe I can avoid having to do any hard work with it. 6 there, 7, 6, 4 and 5, 9 and 7. All these 1 3s still to be resolved. Ah, there is a 1 doing that work for me, if I would only notice it. So that is now a 7. We can, must be finishing off now, and I don't think I'm going to have to think about this cage, thank goodness. In fact, I've got it all now. 3 and 7 there, 4 and 9 here, 4 and 8 at the top, and there we go. And that was just over 1 hour for 7 genuinely approachable puzzles. I mean, numbers 1, 2, and 3, they all slapped me in the face. That one I found very hard. This one, I don't know. I really want to know what the break-in at the halfway stage was meant to be there. And this one I struggled with badly. And again, I might have missed something. It got better after that, thank goodness. And those were great puzzles. I mean, hats off to Clover, Sam, and Philip. Brilliant stuff. Thank you for sticking with this one. I hope you did better on 1 or 2 of the puzzles at least than I did. And hope to see you soon again on the channel. Bye for now.